Hi, so let's continue question number 2. Consider the differential equation dy dx equal to negative 2x over y. On the axis provided, sketch a slope field for the given differential equation at the 12 point indicated. So we got m equal to negative 2x over y. I put the negative side with the numerator. And we have a fraction again. So we say that m equals 0 when the numerator equals to 0. So that means when x equals 0, m equals 0. So we go to x equals 0 and m equals 0. So on each dot, we're going to draw a horizontal line segment. And then m is undefined when y equals 0. So over here, supposed to have vertical line segment, but we don't have to draw it. So right now we're going to continue with the 2 column. So since we are going to draw this column, and we're going to calculate the slope on each point. So we're going to have m equal negative 2x over y. So m equal negative 2 times negative 1 over 2. So we got 1. And we get 2. You got negative 2. And negative 1. So let's calculate the other point also. So we got 1 comma 2. So we still get m equal negative 2x over y. So we get m equal negative 2 times 1 over 2. So we got negative 1. Negative 2. Two. And 1. So we got 1, 2, negative 2, negative 1, negative 1, negative 2, 2, and 1. So now we're going to go back to the column and draw the line segment with the slope 1 on the negative 1 comma 2. So we go 1 up and 1 to the right. So imagine we connecting these 2 points. So we get 2. So you get 1, 2, and 1 to the right. And then imagine you're connecting these 2. And then you get negative 2. So you go 1, 2, and 1 to the right. So imagine you are connecting this negative 1. So you got 1 down, 1 to the right. Imagine you're connecting them. So we finished the first column. Let's go to the next column. So we got negative 1. So you go 1 down, 1 to the right. So imagine you are connecting these 2 points. And then you have negative 2, 1, 2, and 1 to the right. So imagine you're connecting these 2 points. And then you get positive 2. You get 1, 2, and 1 to the right. Imagine you're connecting those 2 points. And then you get positive 1. So you get 1 and 1. Then you imagine you are connecting them. So we finished the slope field for part A. Let's go to part B. Let y equal f of x be the particular solution to the differential equation with the initial condition f of 1 equal negative 1. When equations for the line tangent to the graph at the 1 comma negative 1 and use it to approximate f or 1.1. So we're going to do tangent line approximation again. So that means we have to do y equal mx plus b, and we're going to use the point xy, and then m, we're going to be using dy dx, just like the previous question. So if m equal dy dx, so we're going to use the equation negative 2x over y. So when x equal 1 and y equal to negative 1, so we got negative 2 times 1 over negative 1, which is going to be 2. So we get the slope, you get x and y, and we go back to find b. After we found b, and then we got the equation of tangent line, and we're going to use the equation of tangent line to approximate the value f of 1.1. So now let's find what b equal to. So we got negative 1 for the y, and then 2 times 1 plus b. So negative 1 equal 2 plus b. And then we got b equal negative 3. So we got y equal 2x minus 3 is the tangent line. So when we get to tangent line, we're going to use the y equal 2x minus 3 to approximate this one. So we say f of 1.1 is approximately 2 times parentheses minus 3, and then we can substitute the 1.1 into the x. So next step, just calculate. So we say that f of 1.1 is approximately equal to negative 0.8. So we finished part B. Part C. Find the particular solution y equal f of x to the given differential equation with the initial condition f of 1 equal negative 1. So that means we have to find a general solution and then use the general solution and 1 comma negative 1 to find a particular solution. So let's go back to the differential equation, which is dy dx equal negative 2x over y. And then we do cross multiply, and from there we are going to find the general solution. So we get y times dy equal negative 2x times dx. And I'll do the integral. And then next we're going to follow our integrating process. So the antiderivative y will be y squared over 2, and the antiderivative for the negative 2x will be negative 2, and then this is 1, so therefore it's going to be x squared over 2, and then plus c. So we want to get it off the 2, so next is times 2 both sides. So we got y squared equal negative 2x squared plus 2c. And we're going to let k equal 2c. So we got y squared equal negative 2x squared plus k, and y equal plus minus square root of negative 2x squared plus k. This will be the general solution. So after we get the general solution, we still need to find a particular solution. So we know f of 1 equal to negative 1. So because this is negative, so we're going to use y equal negative square root of negative 2x squared plus k. Now we're going to do substitution. Because both sides negative, we divide by negative. So I get 1 equals square root of negative 2 plus k. And then we're going to do square both sides. So we got 1 equal negative 2 plus k. And then plus 2 both sides, so k equal 3. So now we get k equal 3. So the particular solution will be y equal negative square root of negative 2x squared and plus 3. Now we finish our question number 2.